Assalamualaikum. My name is Muhammad Nufami bin Muhammad Mansur. My matrix number is CE250099, and I'm going to present to you guys about our group project presentation for our course, power generation, transmission, and distribution, BEV20903. Our group is group 2, and our lecturer is Madam Rohaiza binti Hamdan. I'm going to introduce our group members. Our group consists of 5 members, and the first one is Ala Shakira binti Abdul Qadir. Her matrix number is DE250103. And the second one is Fatin Shakira binti Muhammad Shamsul Hisham. Her matrix number is DE250091. And the third one is Nurin Hanis Farzana binti Faizal. Her matrix number is DE250097. And the fourth one is me, Muhammad Nufami bin Muhammad Mansur. My matrix number is CE250099. And the last one is Daniel Hanis Anaki bin Ahmad Kaspi. His matrix number is CE250008.
With rising global electricity demands and growing concerns over environmental pollution caused by traditional fossil fuels, the shift toward sustainable alternatives has become more critical than ever. Renewable energy technology has emerged as a vital solution to combat climate change, reduce greenhouse gas emissions, and secure long-term energy independence. Over recent years, significant technological advancement and dropping manufacturing costs has made this energy solution highly efficient, reliable, and accessible for everyday residential use. Among the various options available, solar photovoltaic technology stands out as one of the most popular and rapidly growing sector. Solar PV system allows households to harvest abundant natural sunlight and convert it directly into clean electrical energy to power various household appliances. The technology not only offers the environment-friendly alternative to traditionally alternative power, but also protect owners from rising electricity tariff. To maximize the benefit of this technology, many modern setups are designed as off-grid systems, operating independently from the traditional electrical grid. And off-grid system generates and manages power entirely on-site. By utilizing dedicated energy storage, it ensures a stable, self-sufficient, and reliable power supply to meet a household daily electrical needs without any reliance on utility companies. Aligned with this approach, this proposal focuses on the design and construction of an off-grid solar energy generating system for a private resident in the Haji Jamil. The primary objective of this project is to deliver a fully self-sufficient and eco-friendly energy solution tailored to lower traditional energy dependency while providing a long-term sustainability for the household. So next, I'll talk about problem statement. Currently, the residential sector, including the private home in Haji Jamil, remains heavily dependent on conventional grid electricity supplied by central alternative providers. This high reliance introduced several cyclical socio-economic and technical challenges. Most notably, the continuous surge in electricity tariffs and unpredictable pricing structure that impose an escalating financial burden on households year after year. Furthermore, because conventionally grid electricity is primarily generated through the burning of non-renewable fossil fuels like coal, oil, and natural gas, this ongoing consumption contributes significantly to environmental degradation, greenhouse gas emission, and global warming. As environmental pollution worsens, continue to rely on this depleting and carbon-intensive energy source, it becomes both ecological and ethically unstable. Because economic and environmental concerns being tied entirely to the traditional centralized grid compromises a household's energy security. Residential areas are frequently vulnerable to expected power outage, voltage fluctuation, and grid instability, which disrupt daily life and highlight a severe lack of energy independence. To address these pressing issues, there is an urgent need to transition toward a decentralized, self-reliance, and cleaner alternative. Consequently, this project proposed implementation of an off-grid solar photovoltaic system for the resident by shifting from conventional grid dependency to on-site renewable energy generation. This system provides a highly sustainable, cost-effective, and autonomous power solution. This approach effectively mitigates the long-term financial pressure of rising utility expenses while eliminating the carbon footprint associated with residential energy consumption, ultimately ensuring long-term energy security and sufficient for the household.
Okay, so moving on to the next slide, that is objective. So there are four objectives that we need to succeed. That is, the first one is to calculate the electrical load requirements of the chosen building. Second is to design a prototype of the renewable generation model of the chosen building. The third one is to analyze the economic advantage of the proposed renewable energy system. And the last objective is to examine the differences in the environmental impacts between conventional power generation and the proposed renewable energy system.
Hi, my name is Muhammad Nofami bin Muhammad Mansur. My matrix number is CE250099, and this is complete documentation of our group for Mr. Jamal's house. On the left picture, as you can see, is our electrical floor plan for Mr. Jamal's house. It include the floor plan and the legends. On the legends, as you can see, we have list our the electrical that we use and the units such as for socket we have 24 units, panda floor lamp 18 units, ceiling fan 7 units, air condition 5 units, military electricity 1 unit, fan switches 7 units, and one way switch 11 units. And for our on the right side of the pitch, on the right side you have residential distribution board schematic. This uh, this picture this schematic have all the lists and the circuit that is using of our electrical. And for RCCD1 we have 100 ampere 30 milliampere, and RCCD2 11 ampere 100 milliampere. This is track back to our MCCB and RCCB usage.
Moving on to the calculation analysis slide, here we evaluated equipment categories for the residents. There are three main highlights from this table. Our socket outlets are the highest consumer using 1,440 kilowatt hour per month. The five air conditioners follow closely using 900 kilowatt hour per month. In conclusion, the total energy demand for this house sum up to 3,314.70 kilowatt hour per month. This high demand justifies our off-grid solar system choice. Next, let us look at the core electrical parameters derived from our analysis. First, our total connected load is exactly 23,760 watts, giving us a maximum demand of 14.12 kilowatt amperes. To find the design current, we split the system into two load types. For resisting load, we use power divided by voltage, where our socket draw the highest current at 52.17 amperes. For inductive loads, we factor in a 0.85 power factor, where our fender floor lamps draw 3.68 amperes. In total, the total design current for the entire installation is 109.22 amperes. Now, let us look at our energy baseline. Our average monthly consumption is 3,314.70 kilowatt hour, which equal an average daily usage of 110.70 kilowatt hour. Looking at CNBB bill calculation on the right, we apply Malaysian residential tarif. After calculating all 5 blocks and adding the 8% service tax, the total monthly cost is 1,916.34 ringgit Malaysia. This highly money expenditure is the primary reason for our transition to a renewable energy solution. Finally, for the solar system design, we followed four key steps. First, for PV power, we divide our daily consumption by 5 sun peak hours and apply a 0.5 efficiency factor, resulting in 33.147 kilowatts. To achieve this, we require 111 solar panels. Next, for storage, we calculated a battery bank capacity of 3,197.05 ampere hours. This calculation accounts for an 80% depth of discharge and a 48-watt system. To organize this capacity, we need 22 parallel strings based on the 150 ampere hour battery rating. In summary, this revolves of grid system is perfectly sized to meet the household high energy demand independently.
Okay, our team is presenting the final design of an grid solar system for Haji Jamil single story house. This 2D diagram shows how electrical power flows from the sun to the house. The entire system is independent, meaning it does not rely the national grid TNB. The solar generation part. First, look at the left side of the diagram. This is the DC generation system. Based on our calculation, we are using very large solar panel array of 30.147 kilowatt. This consists of 111 units of 300 watt panels to capture maximum sunlight. The power flow into the solar charge controller MPPT will safely charge our battery bank. This battery bank is used 48 volts with 3,197 milliamp hour capacity divided into 22 strings. This storage ensures Haji James has free reliable electricity during the night and on cloudy days. Next, the power goes to the inverter. Its job is to convert the stored direct current DC electricity from the battery into the alternating current AC electricity at 230 volt single phase, which is what standard home appliance use. Finally, the AC power enters the house split distribution board, split DB. For safety, we use a split DB configuration to cater different loads. The power enters to the main switch now 63 ampere and splits into two protection level CCB1. First, this protection, the fixed load, we connected to into lighting fan, aircon 5 unit and water heater. CCB2, this has very high sensitivity for human safety. We connect to all 24 power sockets. Outlet to instantly trip and prevent dangerous electricity shock from the residents. So moving on to the next, recommend MCB and RCCB. So I will show the recommend MCB and RCB we use. We use brands Snyder. This is 20 ampere rate current and 6 ampere. And the last MCB we use is 16 ampere. Also Snyder. So for the RCCB, we also use brand Snyder, which is the rated current. Both is 100 ampere, and one is 30 ampere, and one is 100 milliampere. 30 milliampere we use for water heater because water heaters must use higher sensitivity leakage. So for a safety reason.
Okay, so moving on to the next slide, that is discussion. So we conclude that the proposed off-grid solar PV system is able to provide enough electricity for this single-story house safely and efficiently. The MCB and RCCB are used to protect the electrical system from overload, such as short circuit and also electric shock. And during the day, the solar panels generate electricity while the batteries store extra energy to be used at night. So this system also helps to reduce carbon emissions and is more environmentally friendly than conventional power generation. Okay, so lastly, in conclusion, our proposed off-grid solar PV system is able to supply the electricity needed for Haji Jamal's house safely and efficiently. Although the installation cost is quite high at the beginning, but the system can help reduce electricity costs in a long term. So in addition, it uses clean solar energy, which is more environmentally friendly than conventional power generation. So that's all from our group project assignment. Thank you.